welcome back all of you, and like this is the second part of photogeology in terrain evaluation, and I hope there are few students or the participants from the previous course also who took the part 1, and in particular this portion of photogeology in terrain evolution, we will emphasize more on how to identify the landforms mainly, and partly of course we did in the previous one, and we will emphasize more on the physical and structural geology part, and then how to identify the lithological variants on the surface based on photogeology interpretation, okay, or we can say the photo interpretations mainly. We will definitely use the high resolution satellite data, and if possible we will use the color aerial photographs also to show you that how we can identify the different landforms, how to prepare the maps, and why the understanding of the terrain is so important for all of us. Okay. Now I would like before I get into the details, I would also like to talk about that for the country like India, okay, which is now in a phase of infrastructure development. Okay, we need to have a very detailed understanding of the terrain before we get into the construction. Okay, so this is very much important, and let me share with you that there are many projects which are coming up in Himalayas or in the hilly terrains, and even in the Indo-Gangetic plains. Anywhere you go, you need to have the complete full understanding of the geological structures, okay, because without that you will not be able to go ahead with your project. We also have to look at that how the project will be cost effective in terms of the time, in terms of the money which you are going to put there, and of course the most important part is the safety part. Okay, so those all things like we have to take into consideration before going off for any major projects in Himalayas, okay, or in anywhere in the Indian part. So we will try to talk about of course the landforms will remain more or less similar around the globe. If you take fluvial, if you take aeolian, that is the landforms formed due to the wind action, or the coastal landforms, they will remain the same. So we will be using some data from India as well as from other countries or the other part of the globe to make you feel comfortable and understand easily. Okay, so that is our aim, and we also will look at some exercises, okay, or the lab oriented, which we did in the last time in the part 1. So we will try to cover that also, where you will learn that how to use the photographs or the satellite data to identify and delineate or demarcate the landforms. Okay, so with this short introduction, let us move ahead and start this with this part of the course, photogeology in terrain evaluation. So this as I discussed, that this is a broad course content, but I would say that we will not restrict to the exactly what we are talking here, like we will try to cover all, but in some of the lectures you will find that you are having an the part which is of either lithology or the coastal. So as and when we move in this course, we will what I would like to say, that we will try to cover most of the parts which are listed here. Okay, so this is what we say, that geological structure aerial interpretations. Okay, so based on the high resolution satellite photos or satellite data, we will try to evaluate or we can say identify the landforms and evaluate the terrain. Okay. So, what is this is the basic some of you must be aware of what is the structural geology, mainly because this deals with these structures which are created by ongoing deformation or by erosion. Okay. But mainly we will be looking at in this part we will be looking at the deformational structures, okay, like fold, fault, joints. Briefly I covered in one of my course which was offered long back, that is Earth Sciences for Civil Engineering, but I would like that for the new candidates or the students who have joined this course, it is important for them also to have a link between what we are going to use as an photo interpretation and then the evaluation of the terrain. Okay. Now, the structural geology is a branch of geology where geological structure in rocks are studied to understand one is their origin, occurrence, time frame and causes. Okay. So, how they were formed and what was the timing of their forming and how active they are, because we, as I told, that we will be more interested in understanding that how vulnerable these structures are to the society, okay, or the people who are living there, or if you are going to have some transportation links like roads, or maybe you can say highways or tunnels or bridges. So, this is extremely important, and let me tell you that this basic information will be required by each and every project which is coming up in India in such terrains. Okay. So, this is very important from that point of view. So, any deformation if you take and consider on the earth's surface will result into the attitudes in the rocks. Okay. And this is not exactly the attitudes which we are talking. Of course, we have attitudes in our lives, but this is and most of the people will show the attitudes, but these are the attitudes of the rock. Okay. So, as soon as you deform the rocks, they will lead into folding, okay, and fracturing. So, if you keep on deforming the earth's surface or the crust, okay, and this is also already linked with which we talked in the previous course and all that, this is linked with the, or you can connect this with the plate motion. Okay. So, plate tectonics plays an important role where two plates either collide or past each other or move away from one another. They will result into such deformational features. Okay. And we have to live with this features, like for example, we have Himalayas. Okay. So, Himalayas were formed because, and still they are developing. Okay. They are growing because of the ongoing deformation. So, we need to understand that process, and to some extent we have there are well established research outputs which talks about that how the Himalayas were formed, but still we are unable to pinpoint that exactly where the fractures or the fault lies, which we need to avoid. Okay. We cannot put the structures on those geological features. Okay. We have to avoid those. So, if you look at in this broader picture, what you see is that there is the base, if you see there is two like tractors or maybe the bulldozers are deforming the material, and as a result of that what we see is the complete folding. Okay. So, we have the folds, and at some point we have the plane along which the deformational features will move. Okay. And this is what we call as in faults. Okay. And in general, if you look at this feature, we term this as an anticline, and associated depression along with this is termed as synclines. Okay. So, we will have, if you are having compressional tectonic regime or the area in compression, then you will be able to see the features like folds, and folds will be always having association associated with anticlines and synclines. as well as faults, okay, because there is a displacement along these fractures. I will briefly talk about that what is thrust and all that, but if more details are required, you may please refer our previous lectures to make yourself comfortable in terms of the terminologies, okay. So attitudes in the rocks, as soon as you like deform any rocks here, like because usually it is a thumb rule which has been taken that all deposition of the material will take place in an horizontal fashion, okay. So you will have, for example, you have this layers deposited, okay, and when you deform those, okay, then you will see that they are folded, okay. So this is what you see in the upper the sketch which has been shown in on the top, okay. So now there is deformation when it has taken place. What has happened, this all layers were horizontal, okay, but now this layers when they are folded or deformed, they are having some attitudes, okay. So that what we call as in the so they will have some attitudes in terms of the strike and the depth, okay. The layers got inclined. So that is extremely important for us when we talk about the attitudes in the rocks, okay. So rock masses or layers are stratified, okay, when subjected to tectonic forces, they will either get tilted or bent, okay. So they will either get tilted, or you can say they will be a sort of an bending effect, okay. So this is one thing which we have to keep in mind, and this tilting or inclination results in two important structural elements which defines the attitude of beds, okay. So beds, what I means is that they were deposited in horizontal fashion. So these are all horizontal beds or strata you can take, okay, and then they got deformed. So the deformation will, with respect to horizontal, will result into the two attitudes that are your strike and dip, okay. So we will quickly look at then what is strike and what is dip, and we will move ahead in course, okay. Now this you will be able to see only if you are looking at the section, but based on the photographic interpretation, you can also judge that what type of feature or the landform you are looking at, okay. So that is the important part, but without having this understanding what I am talking about, the attitude of rocks and all that, you will not be able to go ahead, because final interpretation of the map which you are going to prepare will require this information, okay. So after doing your satellite data interpretation or photo interpretation, of course you will have to go for field check to few locations, okay, not the complete area, and that is the advantage of this course, okay, or maybe the aspect which we are talking about, the photo interpretation, because otherwise in the earlier days where we were not having very high resolution satellite data, everyone has to go in field and do the mapping, okay. That is what typical structural geological mapping we have to do, okay, and prepare the detailed map. But now on the based on the high resolution satellite photos, at least you can prepare the preliminary map. Of course you can also finalize it, but a field check is required to some locations, okay. Another part is that why this is advantageous, because you will not be able to move or approach or reach each and every location because of some reasons, okay. Either the roads are not there, no connectivity, or maybe it is under thick forest, okay. So you may not be able to approach those areas, okay. So satellite data will give you an idea, an over bird eye view, or you can say in the synaptic view, where you can look at the terrain and identify the area locations of the landforms, okay. Now coming to the strike is an imaginary line on the surface that marks the direction of intersection of bedding plane within horizontal plane. So I'll come to that the picture, but I'll just draw here so that you are able to understand. As I told, that we have horizontal beds, and then when they are folded. Okay. Now, when this inclination of the beds are there, so with respect to this, okay, this is the line here, and the plane which will be joining here will be this one. Okay. So, this is an imaginary plane which you will draw or will make it as a horizontal plane. Okay. So, that will give you the strike of the inclined beds. Okay. So, this is what you can see in a simple example. If you take an top of the hut or a roof of any house where you are having two inclined surfaces. So, the horizontal plane which connects this line, okay, with respect to the inclined one. So, for example, what you are taking is that you are having an inclined plane here, okay, and you are having this is your imaginary horizontal plane. So, the direction of the strike will be this, okay, of this inclined bed, okay, and perpendicular to that, okay, will be your depth direction. So, this is very important, that how the structure is oriented, okay, is one, and how this one, what is the amount of depth of the plane. Okay. So, this is very important for us to identify. So, even from the satellite photographs, you will be able to identify that how steep the surface is dipping. Okay. So, that is very important for all of us, because nowadays you might be watching in the news that there is a lot of landslides and there is a lot of rock falls in many countries, mainly in the hilly terrains. Okay. And this is because you have the steeply inclined beds and fractured rocks, okay, or maybe you can say the faulted rocks. Okay. So, this is I hope this is very clear. So, this is an example which has been given of an house top, okay, where you can draw a line with respect to the horizontal plane intersecting at the top, which will be a strike direction. Now, the strike direction can be given like it is traversing, for example, east west, okay, but the direction of the dip will be in one direction only, okay, because you cannot have the direction. You can say the strike is east west and perpendicular to that will be your dip. Okay. So, that is your dip direction. So, you can say that the beds are dipping towards south, and the strike of the beds are that is inclined beds are east west. Okay. Another example which has been given here is the section has been shown, and the top view is there where you see the inclined beds and or the succession of rock succession, which again is showing the strike, that is east west, and the direction of the dip is here. Another part which is important is your the amount of dip. Okay. And amount of dip will be always taken with respect to again horizontal. Okay. So, what is the angle of dip? You can see here what I am showing is, okay, fine. So, you are having an inclined bed. So, you have this is an inclined bed, and then you are having the dip strike direction is this one. Okay. And amount of dip is what you will say first, the direction, this is the direction here. So, this direction, and then amount of dip is this one. Okay. So, you will measure the angle with respect to horizontal. Okay. Now, to some extent you will be able to cater this information from the satellite data, provided your photographs are ortho-rectified. Okay. And that we did in the previous part, okay, part 1. So, if they are ortho-rectified, exactly the camera is looking perpendicular to the surface, then you will be able to do something related to the strike dip at least. Okay. But dip you will have to check at least in some locations in the field. Okay. So, the compass direction is usually expressed as a bearing, that is north 30 degree east. This is an example which will tell you the strike of the or maybe you can say north 30 degree west. Okay. So, this is a strike directions you can put. So, everything you will talk about with respect to north. Okay. So, one thing which I would like to explain here is that suppose you take this, for example, this is your north, south, and then you are having the east and west. Okay. So you can either use this 2 quadrant on the top and then say, okay, fine, this is your strike direction. Okay. So say around, like, so you can say north 45 degrees east, or you are having somewhere here, so you can say, for example, north 20 degrees west. Okay. So one will be easily can make out, and you can add one 8 here, and then you can have this direction also. Okay, fine, there is absolutely no problem. So if you write in your report or mark on your map this 2 information, that will suffice your case. Okay. So this is one. So let's move ahead and see what is the dip, how we will talk about the dip. So dip again is an imaginary line constructed downslope on a bedding plane that marks the direction of inclination. Okay. So as I told, the direction of inclination, so here you will only be able to give one direction. Okay. So dip direction is always taken perpendicular to the strike direction, and this is termed as the true dip. Okay. So if you have the strike direction here, okay, say north south, then perpendicular to this will be your dip direction. Okay. So this is termed as true dip. Okay. So dip, angle between inclined bed and an horizontal plane, it is expressed as that is 25 degrees southeast or 25 degrees southwest, whatever you get. Okay, fine. So what we are doing is that we are giving only one direction, that is either if it is, for example, it is dipping in this side, okay, in the quadrant, then we will say southeast. Okay, and then amount of dip, and amount of dip, as I told, that if you take the with respect to the horizontal plane and you are having the inclined plane here, okay, then this will be your amount of dip. Okay. So for example, if you say 25 degrees and dipping towards whatever the quadrant you are coming across. Okay. So that will be, and this will be your strike. Okay. So dip direction will be this, amount of dip will be this one, and in whatever quadrants you are having. Okay. Now if you measure the dip which is in any other direction than the perpendicular, okay, to the strike, then we call that as an apparent dip. Okay. So this you will have to take into consideration, and in most of the locations which face you are observing will be very important, because that will lead to the measurements of the apparent dips. Okay. So this is, for example, on ground surface or the earth surface, you will not be able to see the complete structure, because there is there are process going on which will keep eroding this all features and keep modifying the landscape. Okay. So over the time you will be left out with some features on the surface which will not exactly give you the idea of the complete fold. For example, in this sketch, both the actual landform as well as the eroded features are been shown, okay, or the left out features are been shown here. So based on that, you will have to identify what structure it is. Okay, either it is a fold or a syncline, or so what is happening here is, very carefully you should and try to look at. We are having the beds here 1, 2, 3, and then we are having a very broad flat area, and then again we are having the beds 1, 2 and 3 here. Okay. Now both are dipping in different direction. Both are dipping in different direction. Of course, you will be able to make out the strike, because as I told that if you put an imaginary plane here, okay, and then you put a line here connecting the bed, then you will be able to identify the strike. Okay. But with respect to what is the amount of dip here, you will have to look at, because both the sides you are having different dip directions. Okay. So one side the dip is in this direction, another side is dip in this direction. Okay. So this is what we call the reconstruction of the landforms. Okay, so you will have to reconstruct the landform and give your interpretation. Okay, so what we can do is, suppose the geologist going into the field, and based on the change in the dip direction, okay, and here what we are able to see that the dip are the beds are dipping in different direction away from each other. Okay, so when we say away from each other, then when you reconstruct this, for example, this is one bed here, I am very crudely drawing it, there is another, sorry. So if you put this will go here, another one, if you put this will go here, and third one is here. Okay, so this is what you see at the backdrop is your fold. Okay, and this is what we call anticline. Okay, this we can see. Now if you come across this section, it's well and good, and most of the time what we do is that when we go in field, the best areas to look at such sections are your either the river outlets, okay, where a river has cut across the folds or the structures, or you may see in some areas where the road construction is going on. Okay, that also helps us in evaluating the landscape. Okay, so this is the part which we can do. One is that the true dip and the apparent dip part, and then if you are having the beds dipping in different direction, you can identify that what sort of deformational feature it will be. So this is the part of the apparent dip. So suppose you are having the inclined plane, and that this is a strike which can be easily done, and when you are measuring the dip amount, okay, so you will be putting your compass in a particular direction to take the dip amount. So if you take exactly perpendicular, which you can try, okay, then it will be in true dip, but any other direction if you are coming across, then that may be your apparent dip. Okay, and that you can easily get it, you can know based on your strike. Okay, so for example, you are having a strike here around 40 degrees, okay, then the dip direction will be, you can take as an perpendicular to that. Okay, so you add 90 here, so you are having 130, and this will be amount of dip here. Okay, that is for 45 degrees. So if you are measuring the dip exactly perpendicular 90 degree to the strike, then you will, whatever you measure will be your true dip. Okay, but if you are measuring in any other direction, okay, suppose your strike is this, and then you are putting your compass something like this, because you, whatever the face is exposed, you will try to measure it. Okay, then you will get the apparent dip. Okay, so true dip and apparent dip, if you take, the true dip is the dip angle of a bed which is measured right angle to the strike of the bed, and the dip angle measured in any other direction with respect to the strike, okay, other than the true dip direction, is termed as apparent dip. Okay, and this is one very important point, is that apparent dip is always less than the true dip. Okay, so we'll stop here and we'll continue in the next lecture and see more on the photo interpretation part. Thank you so much.